Free fall motion. What is meant by free fall motion? Free fall motion is basically the motion of all the object with the gravitational acceleration. As we know that the value of gravitational acceleration is same, which is 9.8 meter per second square. So all the objects that are near to the surface of Earth, these are attracted towards the Earth with the same acceleration, which is known as gravitational acceleration. And this motion is basically called as free fall motion. So first of all, we have see here the motion of the falling object without air resistance. Air resistance is the force that opposes the motion of the object. I can simply say that it slows down the object. First of all, we have to ignore the air resistance and see the motion of the falling object. In the figure, there is a ball and feather system. Feather and ball, both of these are moving towards the earth. The mass of the ball is larger and for the feather, it's a light. The mass is smaller. So when you drop both of these simultaneously, they move downward because of the attraction of the gravity. Both of these moves downward because of the attractive forces of the earth. So if you ignore the air resistance, both of these, ball and feather, moves towards the earth with the acceleration, which is the gravitational acceleration g. Its value is 9.8 meter per second square. So all the object moves towards the earth with the same acceleration. This acceleration is basically known as acceleration of free fall or acceleration due to gravity. It is given here. Drop a ball and feather simultaneously. Both will fall downward due to gravity. Gravity is the attractive forces of the earth on the object. Neglecting the air resistance, both objects fall with the same acceleration of 9.8 meter per second square regardless of mass. The mass is not the main factor here. All the objects, either they have large mass or the small mass. All of these moves towards the earth with the same acceleration, which is 9.8 meter per second square. And this acceleration is known as the acceleration of free fall. It is also be called as acceleration due to gravity or the gravitational acceleration, and it is represented by the symbol g. The value of g is 9.8 meter per second square. Here is a simulation related to free fall motion. So let's open this. So here you can see that there is a building which is very high and its height is almost 45 meter. When you drop the object from this height, either these are lighter or heavier object. All of these moves towards the earth with the same acceleration, which is 9.8 meter per second square. So let's play this. You can see first of all the small object is dropped and see the time for that. It takes 3 seconds to strike the ground. I play this again. Now in this case there is a heavier object. This object also takes 3.0 seconds to strike the earth. Again you can see that there is object that is not too much heavier and not light. It also takes the same time to reach the earth. What does this mean? It means that all the object, the mass doesn't matter. These are lighter or heavier. All the object moves towards the earth with the same acceleration because these are freely falling. Next is the motion of falling object without air resistance. We have to explain it. Acceleration due to gravity means that the gravitational acceleration or free fall acceleration is same for all the object. Either these are light or heavy object. They fall near the Earth's surface. Therefore, for all the free falling object, the value of acceleration is equals to g, which is free fall acceleration, and its value is 9.8 meter per second square. It means that any object that is moving towards the Earth, it is falling freely. I can simply write here, as you know, acceleration is change in velocity, v over t. So if I replace a with g, which is acceleration due to gravity, I write here v over t, and its value is 9.8 meter per second square. Now I am going to rearrange this equation. G is equals to v over t. It would be 9.8 meter per second over 1 second. I can simply say that all the object that falls freely, during 1 second, their velocity increased by the factor of 9.8 meter per second. Because here the speed is 9.8 meter per second and the time is 1 second. So in 1 second, the velocity increased by 9.8 meter per second. This is only true for the free falling object, not for all the object. As long as air resistance remains small, the speed of the falling object increases steadily, becoming larger the longer it falls. Because when object takes long time, it means that the speed is increasing. If I suppose that here the object takes 5 seconds to reach the Earth, then how much speed would it have? It would be 49 meter per second. So that when you divide 49 with 5, you get the acceleration, which is 9.8 meter per second square. So I can simply say that when the object that takes longer time to reach the Earth, their speed is also increases according to that. During the free fall motion, how many forces are acting on the object? If I suppose that there is a ball, this ball is falling freely. Here I ignore the air resistance, it is negligible. It means that there is no force acting on that object to opposes its motion. So only one force, which is the weight acting on that object, which is acting towards the ground. So on all the freely fall object without the air resistance, only one force acting on them, which is their weight. So it is written here, during the free fall motion, only the force acting on freely falling object is its weight. You can see here is the freely falling object, and here I ignore the air resistance. So only the force that is acting is in downward direction, which is the weight. And we know that acceleration here is constant, whose value is equals to free fall acceleration, and it is 9.8 meter per second square. So this value is constant. When the acceleration is constant, what would be the shape of the speed time graph? You can simply see here, the speed time graph is given, which is a straight line rising from both of these axes, speed and time. Here when the acceleration is constant, the speed would be uniform. Uniform speed means that body covers equal distance in equal interval of time, so that the acceleration would be constant value. Here is the exam style question that appears in May-June 2019. A brass ball and a feather are released at the same time. There is a brass ball and feather, both of these are released at the same time. On the Earth, the ball reaches the ground first. When both of these are released on the surface of Earth, the ball reaches the ground first. On the moon, they reach the ground at the same time. On the surface of moon, they takes the same time to reach the ground. What is the explanation for this? Option A, both weight the same on the moon. B, both weight less than on the moon. C, there is a greater air resistance on the moon. D, there is no air resistance on the moon. First of all, when there are two objects, brass ball and feather, and they takes different time to reach on the surface of Earth, it means that there would be the presence of the air resistance, because air resistance reduces the motion of the body. It slows down the body. That's why the feather reaches after the ball reaches the Earth. But on the surface of the moon, as both of these hits the ground at the same time, what does this mean? It means that there is no air resistance on the surface of moon. That's why both of the object, brass ball and the feather, reaches the ground at the same time. Let's see the answer and explanation for that. You can see here, the air resistance on the Earth is greater on the feather due to its large surface area than on the brass. As the air resistance on the feather is larger, that's why feather takes longer time to reach the Earth. So the ball reaches the ground first. Because of the reason, the air resistance on the ball is smaller on the surface of the Earth. However, on the moon, there is no air resistance. On the surface of moon, there is no air resistance to stop the feather more than the ball. Hence, both reaches the ground at the same time. There is no air resistance on the moon. That's why both of the object hits the ground at the same time. Therefore, correct answer is D. So let's see option D. In the D, it is given that there is no air resistance on the moon. So this option would be correct, which is D. Next, we have to see the motion of the object in presence of the air resistance. You know that air resistance is any opposing force that resists the motion of the object and it slows down the object. So we have to see the motion of the object in the presence of the air resistance. I suppose that I have any object here and it's falling in the air or any fluid or anything that can easily flow, such as liquid or gases. So I suppose that it's a droplet that is moving in the air. Then how many forces are acting on that droplet? Of course, the weight is acting in downward direction, but no, there is an extra force which is the air resistance, because air resistance we are not ignoring here. So the air resistance is acting in upward direction. It always acts in opposite direction to the motion of the object. So it would be the air resistance acting in upward direction. You can see here there is a falling object and you don't ignore the air resistance here. The two forces are acting. First is the weight and the second one is air resistance. Air resistance always acts in the opposite direction to the motion of the object. This object is falling in downward direction. That's why the air resistance is acting in upward direction. There is a term which is called terminal velocity. First of all, you have to consider the water droplet that is moving through the air. There are two forces acting on that droplet. First of all, only the weight is acting on that, which is the gravitational attraction of the Earth. The weight is always acting in downward direction, and due to this force, due to the gravitational force of the Earth, this object is accelerating towards the surface of the Earth with the same acceleration, which is 9.8 meter per second square. Now, as with the passage of the time, the speed of this droplet increase. With the increase in the speed of that droplet, there is a opposing force acting on that, which is acting in opposite direction. It is the air resistance force. At the start, the magnitude of the air resistance is very small, but with the increase in the speed of that droplet, the air resistance also increase. I can simply say that the magnitude of air resistance is directly proportional to the speed. By increasing the speed of that droplet, the air resistance also increase. So I can simply say that for all the objects that are moving in the presence of air resistance, two forces are acting here, the weight and the air resistance. So I can simply say, when I have to find out the total force in this case, which is also be called the net force, it would be equals to weight minus air resistance. See here, all the forces that are in the direction of acceleration, as this droplet is accelerating in downward direction, all the forces that are in the direction of acceleration, these are written with positive sign. Here I write weight with positive sign, but the air resistance with negative sign, because air resistance is in opposite direction to the direction of acceleration of that object. Air resistance is acting in upward direction and this object is accelerating in downward direction. Both of these have the opposite direction, that's why there is a minus sign with the air resistance force. So the net force in this case would be equals to weight minus air resistance. As with the passage of the time, the speed of the droplet continues to increase, the air resistance also increases, and a moment comes when the air resistance becomes equals to the weight of that droplet. It is because of the reason the value of the weight doesn't change. It has fixed value. The weight does not change. So when the speed increases, the air resistance increase. A moment comes when the air resistance becomes equals to the weight of that droplet. I can simply write here the weight get equals to the air resistance force. When this condition happens, I can simply write here weight, as air resistance and weight, both of these are equal. So I write here minus weight. Both of these cancels each other and the net force in this case would be equals to 0. So I can simply say that when the weight and air resistance, both of these gets equal, the net force on the droplet equals to 0. When the net force is 0, what you can say about the acceleration? According to Newton's second law of motion, F is equals to ma. When force is 0, of course the acceleration would be 0. So acceleration is 0 in this case. When acceleration is 0, what you can say about the speed? I can simply write here acceleration is equals to delta v over delta t. Here acceleration is 0, so delta v would be equals to 0. So here you can see that the initial speed is equals to the final speed. When the speed remains constant, like its value does not change, acceleration would be equals to 0. And this constant speed is basically known as the terminal velocity. You can see here, consider the motion of the water droplet such as the fog falling in the air. You have to consider the motion in any fluid. Here the fluid considered air. The weight of the droplet acts downward and accelerates rapidly due to the force of gravity. As the droplet speed increases, the droplet experiences a force in the opposite direction, which is the air resistance. With the increase in speed, there is a force acting in the opposite direction, which is called as air resistance, which slows down the motion of the object. However, as the speed of the falling droplet increases, so does the upward force. Therefore, when you write the net force on the droplet, it would be equals to weight minus air resistance. As the speed of the droplet continues to increase, the air resistance eventually approaches the weight in magnitude, means that air resistance and weight, both of these gets equal. Finally, when the magnitude of air resistance and the weight of the droplet becomes equal, the net force on the droplet equals to 0. As a result, the droplet has no acceleration. Acceleration would be equals to 0, due to which the droplet moves at the constant speed, which is called as terminal velocity. So terminal velocity is the constant speed at which the air resistance and the weight, both of these forces, gets equal. You can see here there is a falling droplet and there is only one force acting initially, which is its weight. When the speed of that droplet increases, there is another force which is acting on this droplet, which is the air resistance, and it always acts in the opposite direction to the motion of that object. As the speed goes on increases, the air resistance also increases. As we know that the value of weight is fixed, it does not change. So when its value remains fixed, a moment comes when the air resistance becomes too much large that it approaches the weight. Then the air resistance becomes equals to the weight. At that moment, the net force acting on that object would be equals to 0. When the net force is 0, acceleration would be 0, so that the speed would be constant. In this case, the object gets the terminal velocity. So which steps a body can follow to reach a terminal velocity? First of all, when the air resistance becomes equals to the weight of the body. The air resistance and weight, both of these forces have to be equal. Then at that moment, the net force acting on that body would be 0. When the net force is 0, of course, according to Newton's second law, F is equals to ma, force is 0, then acceleration would be equals to 0. Therefore, body has no acceleration. When the acceleration is 0, according to the definition of acceleration, which is change in velocity per unit time, when acceleration is 0, delta V would be equals to 0. It means that the final speed and the initial speed, both of these gets equal, and the body attains the terminal velocity because it attains the constant speed. Here you can see the motion of the skydiver. The motion of the skydiver, you also have to consider here the air resistance, because you cannot ignore here the air resistance. The two forces are acting on the skydiver. One is its weight and the second one is air resistance. So air resistance increases as the skydiver opens his parachute. It is because of the reason the parachute opening has large surface area. When the surface area is large, of course the air resistance would increase. Air resistance is basically the upward force and it increases with the increase in speed of that skydiver. The upward force of the air resistance on the skydiver increases. As the upward forces increase, decreasing the acceleration of the skydiver. Why the acceleration is decreased? It is because of the reason initially when there is only one force acting the weight, the speed is increasing. When the speed increases, of course the acceleration increase, and with increase in speed there is other force which is acting in opposite direction, which is the air resistance. So when this air resistance become equals to the weight, acceleration is 0. So that's why it is written here that acceleration decreases. It is because of the reason initially the body is accelerating and then after the acceleration become equals to 0. Of course it decreases to the value of 0. As the result, the skydiver decelerates because its speed decreases. The force eventually balanced out means that the weight and the air resistance, both of these gets equal and a new slower terminal velocity is reached. When the air resistance and weight, both of these gets equal, the body attains the terminal velocity. You can see this graph, it is for the motion of the skydiver. There are different points labeled A, B, C, D and F. So first of all, see here the point A. At the point A, the curve is basically the straight. Like if I make here a speed time graph, you get curve like that. It means that here the skydiver initially is accelerating. The air resistance is very small. Initially there is only one force acting on the skydiver, which is his weight. So when there is only one force acting on the skydiver, the air resistance is very negligible. That's why the skydiver accelerates. At the point B, this point basically shows that as the skydiver accelerates, the air resistance also increases. Both of these are directly proportional to each other. I can simply say that the air resistance increases with the increase in the speed of the skydiver. At the point C, as it's a straight line, at this point, the air resistance and the weight of the skydiver, both of these gets equal. When the weight and air resistance, both of these gets equal, I can simply say that the skydiver reaches a constant speed at the point C. So at this point, the skydiver has constant speed. After that, at the point D, as the skydiver opens the parachute, there is a large upward force which causes the person to decelerate. Means that skydiver slows down. Eventually the forces are balanced out and the person reaches a new but more slower constant speed, and this speed is known as the terminal speed, which is at the point F. It means that at the point F, this skydiver reaches the terminal velocity. So the explanation for this graph is given here. At the point A, the air resistance is small and the person accelerates, means that the skydiver accelerates. At the point B, as the person speeds up, the air resistance increases, because by increasing the speed, of course, the air resistance increases. After a while, the air resistance becomes equals to the weight. Then the person moves at the constant velocity at the point C. Point D shows that when the parachute is opened, there is a large upward force which causes the person to decelerate, means that the person slows down. Eventually the force is balanced once more and the person reaches a new but much slower constant velocity at the point F, and this is basically known as the terminal velocity. Here is an exam question that appeared in February-March 2018. The diagram shows a bird in flight. The bird is flying in a horizontal direction to the right. So this bird is flying in horizontal direction to the right, means that in the direction B. In which direction does the air resistance act on the bird? So can you tell me that in which direction the air resistance will act on this bird? Because you know that the air resistance always acts in the opposite direction to the motion of the object. As this bird is flying in horizontal direction towards B, it means that the air resistance would be acting in the opposite direction, which is D. The air resistance cannot act in the direction A or C. It is because of the reason both of these are perpendicular to the direction of motion of that bird. That's why only the correct one is D. Here is answer and explanation. The correct answer is D. The air resistance acts in the opposite direction to the motion of an object. Option A and C are incorrect. It is because of the reason A and C are perpendicular to the direction of motion of the bird. Option B is incorrect. B is towards the direction of motion of the bird. And D is correct because D is opposite to the direction of motion of that bird. Therefore, the correct answer is D. Here is examination tips. Always remember that the air resistance is upward force on the falling object, which increases with increase in speed, but weight always remains constant. The value of the weight does not change. It's only the air resistance whose value changes, and it increases with increase in the speed of that object. Mostly exam question related to the terminal velocity is the motion of the skydivers as they fall. So in the exam, mostly asked question is basically related to the motion of the skydiver. I hope you understand everything very well. So if you find any doubt, you can ask. Thank you.